Welcome everyone. The question that is displayed on the screen, it is a question number 25 part A, and this is from the Physics CBSE 2025 question paper set 1. A 20 microfarad capacitor is connected to a 220 volt 125 by pi hertz AC source. So what is the peak voltage of the AC source and what is the frequency of the AC source, both are given. So they are talking about an ideal capacitor circuit, okay, that we can draw like this way, just like here, it is a capacitor, and it is such a capacitor which have no resistance, and that is an ideal one. Okay, mostly the capacitor that we are observing, most of the cases it have some resistance, so we cannot get an ideal capacitor. Basically we will get a RC combination, but here we are getting an ideal capacitor. So that ideal capacitor is now connected to an source, which is the AC source. Okay, its voltage is peak value is fixed, but it is sinusoidally changing with a particular frequency, and that is sin omega t. So this is my AC source voltage. Okay, the capacitance of the capacitor is given, and that is 20 microfarad. Okay, now what is asked in the part 1? Find the capacitive reactance. The capacitive reactance is defined as Xc, and that is 1 divided by omega into C. Omega is the angular frequency, C is the capacitance, so 1 divided by 2 pi linear frequency multiplied by the capacitance of the capacitor. So 1 divided by 2 pi, the frequency is 125 divided by pi multiplied by the capacitance, so it is 20 microfarad, so it will become 20 into 10 to the power minus 6. Okay, so after that it will become pi here cancels out, so 2 into 125 if we multiply we will get 250. Okay, we'll get 250 multiplied by 20 multiplied by 10 to the power minus 6, 1. Okay, so after that it will become 1, so 250 into 20, it is 550, and 2 zeros are there, so 5000 multiplied by 10 to the power minus 6. So very simply we can write it down: 1 2 3 1 2 3, 10 to the power 6 it gone up, divided by 1 2 3, so 0 cancels out, so 5 divided by 200, so this will become 200 ohm. So that is the capacitive reactance. Obviously here it is a resistance in the AC circuit, so it is 200 ohm. What is the peak value of the current in the circuit? So if you want to find it out, what is the peak value of the current? So obviously we know that V equal to IR, but here what I have to do, the voltage, the peak value of the voltage divided by the capacitive reactance, because here the resistance is not present, here the reactance is present, so it becomes 220 volt divided by the capacitive reactance is 200 ohm. Okay, so 0 cancels out, so obviously here it will become 10 and it will become 11, so 11 by 10 it will become 1.1 ampere. So that is the peak value of the current in the circuit. If the frequency of the AC source is doubled, by what factor will the capacitive reactance of the current be changed? So, okay, this is the part 1 and the part 2 answer. So if somehow the frequency of the AC source is doubled, so from these expressions what you have understood? Okay, if the capacitance is same, then what you have understood? The capacitive reactance is inversely proportional to that of the frequency. Okay, from these relations, that is Xc equal to 1 by omega c and Xc equal to 1 by 2 pi fc. So from here we can say that is the Xc is proportional to 1 by frequency. Okay, so we can write it down: Xc 1 divided by Xc F2 equal to obviously F2 divided by F1. Whatever be the value of the frequency, if the frequency is doubled, that means we can say F2 equal to 2F1. So that is 2F1. Okay, so obviously F1 F1 cancels out, so we can get that XC2, okay, equal to 2 into XC1 equal to 2 into XC2, or XC2, that is after changing frequency, XC2 XC1 before changing frequency divided by 2. What is the value of the XC1? Just we have calculated, that is 200 ohm. So XC1 is 200 ohm. Obviously here XC1 basically saying when the frequency is 125 by pi hertz, and XC2 is the frequency when it is getting doubled. Double means 250 by pi hertz. So obviously I think you have understood that. So 200 by 2, that is equal to 100 ohm. So if the frequency is doubled, then the capacitive reactance is getting halved. Okay, very simply, because they are inversely proportional to each other. Xc is proportional to 1 by F. Okay, thank you all of you.